Next we look on the second question. This is the 23rd question of the GATE exam 2020 for EC department question paper of control system subject. The question is, the loop transfer function of a negative feedback system is the g of s into h of s equal to k into s plus 11 divided by s into s plus 2 into s plus 8. The value of the k for which the system is marginally stable is dash, which mean the what value of the k is the system is marginally stable. That is the question. The solution of the problem. This problem can be solved by two methods. The first method is Rutherford's method and the second method is shortcut method or equating inner product and outer product of the characteristic equation method. Basically, these two methods are required the characteristic equation in order to find stability value. So, now we want to find the characteristic equation from the given a negative feedback system is g of s into h of s equal to k into s plus 11 divided by s into s plus 2 into s plus 8. We know that the general closed loop characteristic equation, that is 1 plus g of s into h of s equal to 0. Now substitute the given g of s into h of s term in general closed loop characteristic equation. Then the next equation will be the 1 plus k into s plus 11 divided by s into s plus 2 into s plus 8 equal to 0. After cross multiplication, then the equation will be s into s plus 2 into s plus 8 plus k into s plus 11 divided by s into s plus 2 into s plus 8 equal to 0. And multiply these three terms each other and multiply k into the bracket in numerator part, as well as do the cross multiplication of the denominator part into right hand side 0. After that, the equation will be the s cube plus 10s square plus 16s plus ks plus 11k equal to 0. Next, take the common term as in third and fourth term of this equation. Then the equation will be the s cube plus 10s square plus 16 plus k into s plus 11k equal to 0. So, this is the required characteristic equation of the loop transfer function of a negative feedback system. First, we will go with the method 1 by Rutherford's concept. Basically, this method is required the characteristic equation. That equation we already found. That characteristic equation is the s cube plus 10s square plus 16 plus k into s plus 11k equal to 0. Now apply this characteristic equation on Rutherford's table. This according to Rutherford's method. By using the order of the s power in characteristic equation, we can formulate Rutherford's column like this manner. This column is the based on the availability of the s power terms in the characteristic equation. Next, we can fill the s cube row by the coefficient of the odd power s terms of the characteristic equation. The odd power s terms are the s cube and s power 1. The s cube coefficient is 1 and the s power 1 coefficient is the 16 plus k. This value can fill in the first row of the Rutherford's table, and the remaining the first row position will be 0. Next, we can fill the s square row by the coefficient of the even power s terms of the characteristic equation. Then the even power s terms are the s square and s power 0. The s square coefficient is 10 and s power 0 coefficient is 11k. This value can filled in second row of the Rutherford's table, and remaining the second row position will be 0. Next, the third row and first position or s power 1 row and first position of the s1 power 1 can filled by like matrix multiplication with this manner and divided by the second row of the first position 10. Then the position of the equation will be the s1 power 1 equal to 10 into 16 plus k minus 11k divided by 10. This term will filled on third row and first position of the Rutherford's table. Next, third row and second position or s power 1 row and second position of s2 power 1 can be filled by like matrix multiplication with this manner and divided by the second row of the first position 10. Then the position of the equation will be the s2 power 1 equal to 10 into 0 minus 1 into 0 divided by 10. Therefore, the s2 power 1 equal to 0. This 0 will be filled third row and second position of the Rutherford's table. Similarly, the continuation of the row will be 0. Next, final row and first position or S power 0 row and first position of the S1 power 0 can be filled by like matrix multiplication of the previous two rows values with this manner and divided by third row of the first position is 10 into 16 plus k minus 11k divided by 10. Then the position of the equation will be the S1 power 0 equal to 10 into 16 plus k minus 11k divided by 10 into 11k minus 10 into 0 and whole divided by 10 into 16 plus k minus 11k divided by 10. After simplification, the S1 power 0 will be the S1 power 0 equal to 11k. This 11k will be filled on the last row and first position of the Router-Wirth table. Next, the final row and second position or the S power 0 row and second position of the S2 power 0 can filled by like matrix multiplication of the previous two rows values with this manner and divided by third row of first position is the 10 into 16 plus k minus 11k divided by 10. Then S2 power 0 equal to 10 into 16 plus k minus 11k divided by 10 into 0 minus 10 into 0 and whole divided by 10 into 16 plus k minus 11k divided by 10. In this equation, the numerator part everything 0, so the S2 power 0 become 0. So the position of the equation will be the S2 power 0 equal to 0. The 0 will filled on the final row and second position of Router-Wirth table. Now apply the concept of the marginally stability analysis on Router-Wirth table in order to find the k values. It has some condition. The first one, the Router-Wirth table should have the row of the zeros other than last row, which mean the Router-Wirth table of the first column has to equate the zeros they accept the last row. In that, the S power 1 row and the first position of the equation contain the k terms, so it must equate to 0. Like this way, we can write the second one is the marginal stability condition is the S1 power 1 greater than or equal to 0, which mean the row S power 1 and the first position is the S1 power 1 greater than or equal to 0. Now substitute the S1 power 1 from Router-Wirth table. Then the equation is the 10 into 16 plus k minus 11k divided by 10 greater than or equal to 0. Is after that the simplification on numerator and the cross multiplication on denominator part, then next equation will be the 160 plus 10k minus 11k equal to 0. In this equation, the subtraction of 10k minus 11k is minus 1k. So the equation is the 160 minus k equal to 0. The finally k equal to 160, which mean the system is marginally stable at k equal to 160. So the answer is the k equal to 160. This is the required answer for this problem. Now we will go with method 2 by shortcut method or equate inner and outer product method from the characteristic equation in order to find the k value. From the characteristic equation, that equation is s cube plus 10s square plus 16 plus k into s plus 11k equal to 0. In this equation, we have to equate inner product coefficient to the outer product coefficient like this manner. The equating term, that equation we can write as the inner product equal to the outer product. In this, the inner product coefficients are 10 and 16 plus k and it has to take the multiplication in left hand side. And also the outer product coefficients are 1 and 11k and it has to take the multiplication in right hand side. After substitution of all the terms, the inner product and outer product term equation will be 10 into 16 plus k equal to 1 into 11k. In this equation, in left hand side part, 10 into 16 is 160 and 10 into k is 10k. After that the equation will be the 160 plus 10k equal to 11k. Next shift 10k into the right hand side, then the equation is 160 equal to 11k minus 10k. In right hand side part of this equation, 11k minus 10k is 1k. So finally k equal to 160, which mean the system is marginally stable at k equal to 160. So the answer is k equal to 160. This is the required answer for this problem. From observation of method 1 and method 2, the method 1 by using the Router-Wirth concept is a little bit tedious and a time consuming process in order to getting the k value. Next, Method 2 by shortcut method or equating inner product and outer product method is easier and less time consuming process in order to find the K value than Router-Witts method.